Thank you very much for coming. I'm not really sure if you would be able to handle two frameworks in a row, but I will do my best to make it as engaging as possible. So this is a paper from the early stages of an EU-funded project called PALRS, which is trying to generate learning analytics in order to support teachers and learners in practice-based learning activities. And these type of learning activities is quite a new context for learning analytics, and there has not been much work done. So I will initially start with introducing what do we mean by practice-based learning activities and what is the specific learning context that we are studying. And the main reason to do this is that it's very untraditional for learning analytics research. I will be continuing with the problem statement and the development process of the analysis framework that we have followed. And I will introduce the initial PALRS system that we have designed within this project. And I will finish with the contributions. And PALRS stands for the acronym for the projects that we are studying, which also gives the names to the learning analytics system that we have. So according to the constructionist learning theory, learning happens by testing one's model of the world through constructing objects. And using this learning theory as a basis, we define the practice-based learning activities as learning through activities in which the learners manipulate and observe real-world objects and materials. So these activities involve all the laboratory work in science education, involve design activities in engineering education, it involves technology design and interaction design activities in technology contexts. And within this broad variety of activities, we focused on physical computing tasks, particularly those that aim to help students to create in a collaborative manner and solve problems collaboratively. So basically, we investigated learning situations in which students working collaboratively using physical computing kits and visual programming. So the ones on the left are the modules of the physical computing, and they use a simpler version of the visual programming, which is also created as part of the project in order to make coding as simple and as applicable as possible to particularly younger students. To design products in open-ended tasks. So these two do not look great, but they're actually student projects. The one on the left is an interactive toy with a potentiometer as a nose of a cat. So if you actually play with the nose of the cat, the LED turns on and off. And the one on the right is a snowman, as you can see. But when you blow to the nose of the snowman, his eyes turn on with LEDs, so it has a temperature sensors in it. So learning analytics is, as we have been already seen with two great presentations, contributing to the frameworks and studying collaboration and problem-solving processes. However, these frameworks, the existing frameworks, are not very applicable in practice-based learning activities. And this is the main reason behind this is that the activities that we are interested in are often open-ended, so they are not very well structured. So as part of the project, okay, we think there's great potential with the learning analytics and we want to support practice-based learning activities, but what do we actually measure in these learning activities? What encompasses collaborative problem solving that we can actually observe? That was kind of the main research question of this specific paper that I'm presenting at the moment. And when we looked at the approaches to create frameworks, we found out that there were two main approaches. One of them was the kind of theoretical model of the process, which is kind of a top-down approach to use what is already existing in the literature, like the second presentation that has been done. Or there was the grounded theory approach in which student activities were observed and the actions that were observed tried to be measured using the certain analytics tools. But both of these activities have their own advantages and disadvantages, because the top-down approach was criticized with the fact that the dimensions that are being defined in the literature are not very observable in the specific contexts, and the grounded theory approach is often criticized with the fact that it is not very applicable to a variety of contexts that you would like to study. So we use a mixed method approach, using both of them in order to create a framework that would help us to identify observable actions of collaborative problem solving in these specific learning contexts that we are studying. And we follow the 3 stages to create this framework. In order to do this, we first obviously have undertaken a literature review, what exists in the literature related to collaboration, what exists related to problem solving, and what actually exists in the combination of these 2 different dimensions, which is collaborative problem solving. And then we have adapted these existing dimensions with the research purposes that we have, which was to investigate these learning processes so that we can provide support with the learning analytics. And then we have identified the observable actions, the fine-grained actions of these dimensions. So the initial theoretical investigation, for this theoretical investigation, we have used the framework that was prepared by OECD. And the main reason for this was that it was one of these rare attempts that actually combined the literature related to collaboration and related to problem solving together. And it is an international organization which also prepares PISA exams, as I'm sure you are all aware, to compare national differences. So it was quite a broad literature which helped us to identify dimensions. So these are the 7 dimensions that are identified from OECD's framework: establishing and maintaining shared understanding, taking appropriate actions to solve the problem, establishing and maintaining team organization, exploring and understanding, presenting and formulating, planning and executing, monitoring and reflecting. However, the existing literature from OECD was not appropriate for our purposes, because OECD intentionally aims to assess students' skills for PISA examinations. But what we wanted to do, actually investigate those processes in order to identify what kind of observable actions could be supported with the help of learning analytics in these specific learning activities, rather than, oh, you are a good problem solver and you are not, or you are 7 out of 10 in collaborative problem solving and you are 8. What does it even mean? So we have added the missing dimensions, which were the lack of identification of knowledge deficiencies and problem scoping. So, and it turned out to be this, which has specific competencies related to collaboration and specific competencies related to problem solving. So, okay, we have this. It looks great, but what does actually establishing and maintaining shared understanding mean, and how we can measure it in the context of learning analytics? So, driven by this question, we have created, okay, this is the learning context that we want to investigate. We will replicate it, and we will tag observable actions of these activities so that we can relate these to the existing dimensions we have identified from the literature. So we created a hackathon event in which 3 groups of 5 secondary school students, they were aged 15 to 14, were assigned to work on an open-ended hands-on project using physical computing tools, Arduino. So they designed similar tools as I have just presented. And we have tagged each observable action that is going on during these activities. And in order to create broadness in these observable actions and to see if there was any differences between adults and students, we have created workshop events involving 2 groups of adults pairs worked on 2 different open-ended hands-on physical computing projects using an Arduino-like kit called SamLabs, collaborating together, and we have again tagged observable actions. In total, we have identified 31 fine-grained actions, and these observable actions then we relate to the dimensions of the framework that we have created. And in order to validate these actions, two coders applied the same codes in a different set of data to see if the tags and the observable actions that we came out were actually applicable in different contexts. So it ended up with being this huge table. I don't really expect you to read it all. I know it's very hard to read, but what I really want you to show you is that we have as problem-solving dimensions the rows, and the collaboration dimensions as the columns, as you can see. And within each cell, we have an observable action that relates to these specific 2 competencies that we have identified. So, okay, now we have the observable actions, how we can go and provide learning analytics to support this in this specific context. So this is where Peller's system comes in, and it is still part of an ongoing project. So we have created this furniture environment in which students can do open-ended physical computing tasks. So we collect data in Peller's, both from ambient and live sources. So we have a computer vision system with facial and object tracking using the fiducial marks. So we look at how students use their hands. Do they use them, like how broadly do they use the table? And we tag students' faces. Whether do they look at the screen? Are they doing programming, or do they look at each other, and how close they are? So we use physical computing toolkit IDEs as part of the Arduino kit that we have created. We record students' programming activities. We have a mobile system in which students document their work. They take pictures, they take notes. And we have sentiment buttons, which are these 2 buttons, as you can see. So when they have a problem, they press the cloud button, and when they think everything is going on, or when they have a bright idea, they press the bulb button. And this table, again, another big one, but I will get into the details, is that it shows the data collectors that we have at the top, which I have just presented, and it also shows the fine-grained actions that we have identified, and we aim to observe using these learning analytics systems. So how do we envisage to use the framework is that, for instance, using sentiment buttons, we would like to have data related to students' ability to identify a problem. And identifying a problem is an observable action that relates to identifying facts as a competency of problem solving, and taking appropriate actions to solve the problem as a collaboration competency. So we are now recently started using and collecting data. The paper that we have sent obviously is from an earlier time, and this is the framework that we have created, and we believe the contribution is that there is very limited work on practice-based learning activities, and there's great potential with learning analytics, and the framework that we have created could provide the learning analytics researchers to create appropriate technologies to observe such actions that would relate to appropriate competencies of collaborative problem solving. And another issue which was actually emphasized by the previous presenters was that there is a lot of literature going on related to the competencies of 21st century and 21st century skills, so-called. But what does it actually mean is very fuzzy in the literature, and how learning analytics could contribute to the observation and support of these skills is very problematic. And this mixed methods approach that we have used, we believe could be appropriately used to identify observable actions of 21st century skills. Thank you very much.
Okay, questions?
Hello, I'm ashamed to say that I'm member of the OECD expert group that wrote this, this framework for collaborative problem solving. It has to be based on the framework for problem solving. So the 4 rows of the framework for problem solving have been mixed with collaboration. And you have to understand that it's a frustrating experience. You have to design a test that measures collaboration in 63 different cultures. So if you say, let's organize a trip to the zoo, say, no, there is no zoo in my country. Every item has to be smaller than 5 minutes, and the skills have to be measured individually. No collaborative situation. Okay. Anyway, just to say that this is a situation of PISA. You will get the result this year. What would be interesting, this is the kind of situation we dreamed about when we built this test. So that if you could get, I don't know how to get the PISA test, and compare how much reality is far from PISA, that would be a fantastic paper.
Thank you very much. I mean, that is an amazing comment, and thank you very much for doing this. As a research group, we are actually aware of many of these issues, particularly my colleague Luckin, who have good collaborations and colleagues working in the preparation of these reports. And we knew this, but I guess the point that I really wanted to make here is that there is a lot of confusion when it comes to when we read these concepts. They might mean different things in our learning context that we are investigating. And for learning analytics researchers, the key point is to create something that is observable for the current technology that we have, so that we can actually use these in order to generate some data. But thank you very much for this comment. I mean, obviously, it all has started from there.
Yeah, I just want to say I agree with Pierre. I'm waiting for that paper, maybe next summer.
Yeah, one thing that's interesting, I got to comment on I was one of the experts who commented on the test, and the first reaction I had is I thought, you know, I teach course on CSCL, and I don't even think my master's students will do very well on the PISA test, because the skills were, you know, it'll be very, very interesting to see the results. But so that's partly what I say, is because we actually have all these learning objectives often that we say at the university, you know, you're going to have collaborative skills when you come out of the course, but we don't really teach it. Exactly. Do we teach them how to collaborate? So that was my question to you in this situation. You're observing collaboration, you're observing what teamwork can be broken down into having a leadership role, etc. Do you teach them at all, or you just let them go at it?
Yeah, well, that's a very good question. I think, but obviously this is not within the scope of this paper, but it has been a while since this paper was written, and the way that we kind of followed this up was to compare groups that somehow succeeded in solving problems collaboratively with those who did not, who failed in solving problems collaboratively. And by identifying different patterns of these observable actions, we try to find out which one of these, or which few of these observable actions could lead to success, or which ones would lead to failure. So by using this information, we would like to provide knowledge to teachers so that they can actually support novice students in those most commonly, in those observable actions which lead to failure in solving problems collaboratively. So we kind of use a comparison of mapping these actions as a way forward. I don't know if this answers your questions. I mean, this is like, we have also done some hand coding, and I'm very happy to show you the differences, but these are not from the learning analytics at all. These are hand coding things, but these are kind of showing the cumulative time plots of different groups, and we compared experts and novices while they are solving problems collaboratively. And it appears like expert learners spend a lot more time in identifying facts compared to the novice learners. So we would like to use this information in order to empower teachers in their practice. Or like it appears that expert learners spend a lot more time on establishing and maintaining shared understanding, whereas novice learners are much more interested in taking actions to move forward. So we are trying to use these type of comparisons to empower teachers in their practice. Well, obviously, these are not like from the scope of this paper, but related to your question, I guess.
Yeah, thanks. Well, just following up on Pierre's point, I was also involved in a project where it was the OECD collaborative problem solving, where they put out a bid to 2 big universities, and they were developing collaborative problem-solving tasks and the associated assessment frameworks for assessing this collaborative competency. And a recent 2014 country report that they gave out to the participant countries was that their assessment framework and methodology was robust, and it was culturally and linguistically non-biased, and invariant was the term that they used across all cultures and linguistic, sort of contexts. And they also had a statement there that said that they analyzed the indicators of these collaborative problem solving. The indicators captured students or learners' hypothesis formulation, idea generation, negotiation, and the irony was that the task is solved by 2 students using an online chat, and the chat was not analyzed. So do you know what I'm saying? Yeah. So sure. The indicators would be, okay, if there were 6 lines of text before they did an action, that was an indication of negotiation. So our little modest contribution was that we obtained our Singapore data and analyzed the text, right, and coded the chat manually according to a framework of collaborative problem solving. And we found very distinctive variations between successful and unsuccessful collaborative problem solving teams as manifested in their talk patterns. So I'm just wondering whether in your study, talk being an explicit action is accounted for or will be accounted for. Thank you.
Thank you very much for your point, and I completely agree with it. I mean, in our research group, and I believe most of you would agree, that we believe technology should be driven, learning analytics technology should be driven with the requirements of education. And these kind of frameworks and analysis approaches kind of help us to decide what kind of technology we need to develop and how we should actually use it. And as it turns out, most of the observable actions that we have identified would actually relate to speech and what do actually students talk. But it is very hard to apply such a thing in practice-based learning environments. So we are planning to do text mining and the data analysis of students' chat through the mobile tool that we have, in which they put input. But we have not developed it yet. As I told you, this is kind of an early stage of the project that we are involved. And yes, but this is one of our future plans. Thank you very much.
Hi, I'm Minchol Kim from Drexel University, and I am a great advocate of constructionism, so I am very happy to have your presentation. So in constructionist learning, the learning outcomes may vary from person to person. So I wonder how you define and measure the complexity and sophistication of computational artifacts that people create in a group setting, and how you measure the an individual's learning out of group setting.
Thank you very much for your question. Frankly, I think that's a very valid point, but as I was trying to answer Barbara's question, what we are trying to achieve is kind of identify what kind of behavior patterns would lead to success, rather than measuring the success as a full concept. And then trying to identify these differences which could be supported. So we are not, at this stage at least, because this, as you are aware of the fact that learning analytics is very new in practice-based learning activities, at this stage we are just trying to identify those patterns which would then be informed which would be used to inform teachers in their own practice rather than creating an automated way of providing support during these activities. So yeah, all these issues that you have just raised are very valid, and I just do not know at the moment how we will get over it. But the point is that even if we can identify one specific action that lead particularly to success in solving problems collaboratively and pass this knowledge to teachers, I think that's a great piece of contribution, in my opinion.
Okay, we have time for just one more question in this session.
Yeah, sorry, just before the question, may I just add, that we have a poster, as I am reminded with my colleague, and so you have, if you would like to see early visualizations and further information about the piece of work, please do come into the poster session. Sorry, I just took your time for
No, not a problem. So you have shared, by the way, this is fantastic stuff, because I also look at building of computational artifacts and kids working in pairs or groups, and so this is great stuff. I was just wondering if you looked at past research in the learning sciences that people have done for decades. I mean, some of them are in this room, people like Pierre and others, and Bridget Barron's work on why smart groups fail, and so there are indicators that you can draw from past research, like turn taking, the amount of or joint attention or things like that. Did you do you find that your success and failure comparisons sort of reinforce some of those findings, or?
Yeah, I mean, as I told you, these results that I have just shared with you are not within the scope of this paper, and they have just recently come up, and we are trying to see how do these kind of results relate to the previous literature. And one of the very interesting research area that we are looking at is the engineering design processes, and the previous research that has been done by Marcelo Worsley and Paul Blickstein. And there are certain similarities. For instance, in their findings, they show, or Atman's papers, they show spending appropriate amount of time in the identification of problem could lead to success in solving problems collaboratively, which kind of relates to our findings as well. But yeah, we are looking at it, and thank you very much for reminding us again. We really would like to make a bigger kind of literature search to see how our findings fits with the broader learning analytics literature. But as I told you, at the moment we just focused on we mainly focused on the engineering design processes, because they kind of relate to the constructionism and practice-based learning activities. Thank you.
Okay, thanks all for a great session, and now for a break.